Chapter 7, Section 1, Interactive Reader, pages 89 through 92. Resources and energy, mineral resources. Key ideas. As you read this section, keep these questions in mind. What are ores and where do they form? Why are mineral resources important? What are 4 ways humans get mineral resources? Page 89, questions. What are the 2 main kinds of minerals? What causes new minerals to form in contact metamorphism? What resources are in Earth's crust? Earth's crust contains many minerals that humans can use. Some minerals are metals, such as gold and silver. Others are non-metals, such as sulfur and quartz. Ores. Minerals can be native elements or compounds. Native elements are minerals that are made of only one element. Highlight. Native elements are minerals that are made of only one element. Gold, silver, diamond, and sulfur are examples of native elements. Highlight. Compounds are minerals that are made of 2 or more elements. Quartz, gypsum, and halite, salt, are all examples of minerals that are compounds. Question number 1. What are the 2 main kinds of minerals? Answer. Native elements and compounds. Native elements and compounds. Highlight. Most rocks contain only 1 or 2 minerals or elements that are useful to people. Continue highlighting. People must break up the rocks or minerals to get the useful materials out. Continue highlighting. This process takes time and energy. Some rocks and minerals contain large amounts of useful materials. Highlight. A rock or mineral that contains a lot of useful minerals or elements is called an ore. Ores can form in different ways. The table below describes different ways ores can form. Process. Cooling magma. As magma cools, crystals of different minerals form. Ores of nickel, chromium, and lead are examples. Evaporation. When a body of water evaporates, minerals that were dissolved in the water crystallize. Halite, rock salt, gypsum are examples. Highlight. Contact metamorphism. Highlight. Magma heats nearby rock. Continue highlighting. The heat makes minerals in the rock react to form new minerals. Examples: ores of lead, copper, and zinc. Highlight. Hydrothermal veins. Highlight. Hot fluids move through small cracks in solid rock. Continue highlighting. Minerals from the rock dissolve into the fluid. Continue highlighting. Later, the minerals crystallize and form narrow veins in the rock. Examples: gold, tin, lead, copper. Question number 2, what causes new minerals to form in contact metamorphism? Answer, magma heats rock. Magma heats rock. Minerals in the rock react. Minerals in the rock react to form new minerals. To form new minerals. Again, magma heats rock. Minerals in the rock react to form new minerals. Page 90. Questions. What is a lode? What are two places where placer deposits commonly form? Ore deposits. When cooling magma forms ores, the ores sink to the bottom of the magma chamber. When evaporation forms ores, the ores sink to the ocean floor. In both of these cases, the ores are clustered in one place. Highlight. An ore deposit is a collection of ores that are all in one place. Ore deposits can form in other ways too. For example, many thick hydrothermal veins may form in one place. Highlight. Many thick hydrothermal veins may form in one place. Continue highlighting. When that happens, they form an ore deposit called a lode. What is a lode? Question number 3. Answer, many thick hydrothermal veins that may form in one place. Veins that may form in one place. Again, your answer should be many thick hydrothermal veins that may form in one place. Highlight. Moving water can also form deposits. When rocks break down, water can wash away tiny pieces of heavy minerals such as gold. When the water slows down, it can no longer carry the heavy minerals. The minerals drop to the bottom of the water. Highlight. They may get trapped in the curve of a river or in deep places on the bottom of a stream. Continue highlighting. As the heavy minerals build up, they form an ore deposit called a placer deposit. Under the diagram, some placer deposits form in places where rivers bend. Others form in deep areas and streams. Highlight that sentence. Again, highlight. Some placer deposits form in places where rivers bend. Continue highlighting. Others form in deep areas in streams. Continue highlighting. The deposits form when pieces of heavy minerals get trapped as water slows down. Question number 4. What are two places where placer deposits commonly form? The curve of a river. The curve of a river Deep places on the bottom of a stream. Deep places on the bottom of a stream. What do people use minerals for? People use different minerals for different purposes. Highlight. Some minerals are valuable because they are beautiful and rare. For example, people use gold, silver, and gemstones in jewelry. Highlight. Gemstones are non-metallic minerals that can be cut or polished until they shine. The table on the next page shows some uses of different minerals. Page 91. Questions. Which two minerals are used to make cement? Why is it important for mining companies to identify places with large ore deposits? What types of mineral deposits can be mined by surface mining? Table. Gold. Uses. Electronics. Dental work. Jewelry. Diamond, a form of carbon. Uses. Drill bits. Jewelry. Graphite, a form of carbon. Uses. Pencils, paint, batteries. Highlight. Calcite. Highlight. Uses. Building materials and cement. Halite, also called rock salt. Uses. Foods, food preservation. Highlight. Kaolinite, a type of clay. Uses. Highlight. Ceramics, paper, cement, bricks. Quartz, found in sand. Uses. Glass, computer chips. Sulfur. Uses. Gunpowder, medicine, rubber. Question number 5. Which two minerals are used to make cement? Answer. Calcite, kaolinite. Calcite, kaolinite. How do miners collect minerals? Mining companies are always looking for new ore deposits. These companies search for places that contain a lot of ores in one area. Highlight. There are several ways that the companies can identify the best mining areas. Highlight. They study local geology. Highlight. They collect and test rock samples. Highlight. They use airplanes with special equipment to find patterns in magnetism, gravity, and rock color. Subsurface mining and surface mining. Many mineral deposits are far beneath Earth's surface. Highlight. Minerals work in underground mines to collect these minerals. This type of mining is called, highlight, subsurface mining. Highlight. Some mineral deposits are close to Earth's surface. They may be covered with a layer of soil or rock. Miners take off this top layer so they can collect the minerals. Highlight. This type of mining is called surface mining. Question 6. Why is it important for mining companies to identify places with large ore deposits. The more ore that a company finds in one place, the more profit they will make. And the lower their costs. Again, the more ore that a company finds in one place, the more profit they will make and the lower their costs. Question number 7, what types of mineral deposits can be mined by surface mining? Answer, deposits that are close to the Earth's surface. Deposits that are close to the Earth's surface. Placer mining. Highlight. Miners can use large ships to mine placer deposits. They attach, highlight, large buckets to a ship. Continue highlighting. The buckets scoop up solid material from the bottom of a lake or ocean. Continue highlighting. Then miners separate the minerals from the other materials. Undersea mining. The ocean floor also contains mineral deposits. However, it is difficult for miners to gather minerals from beneath the ocean. Highlight. Undersea mining is also more expensive than other types of mining. Page 92. Questions. What are ores and why are they important? What is the difference between a native element and a compound? How do hydrothermal veins form? What are 4 ways that ore deposits can form? Where do the minerals in placer deposits come from? Complete the table below. Question 1. Answers can be found on pages 90 and 92. A rock or mineral that contains large amounts of materials that are useful and can be mined at a profit. Again, a rock or mineral that contains large amounts of materials that are useful and can be mined at a profit. Question 2. Answer can be found on page 89. Native elements are made of only one element. Native elements are made of only one element. Compounds are made of two or more elements. Compounds are made of two or more elements. Again, native elements are made of only one element. Compounds are made of two or more elements. Question 3, answer can be found on page 90. When hot water moves through cracks in rocks, when hot water moves through cracks in rocks and leaves behind minerals that it has dissolved. Minerals that it has dissolved. Again, when hot water moves through cracks in rocks and leaves behind minerals that it has dissolved. Question 4, answer can be found on page 89. Cooling magma. Cooling magma. Evaporation. Evaporation. Contact metamorphism. Contact metamorphism. Hydrothermal veins. Hydrothermal veins. Again, cooling magma, evaporation, contact metamorphism, hydrothermal veins. Question number 5. Answer can be found on page 90. Moving water that has broken down rocks. Moving water that has broken down rocks. Question 6. Answers can be found on page 91. For subsurface mining, description: miners take minerals and rocks from underground. Miners take minerals and rocks from underground. Surface mining: miners remove soil. Miners remove soil and take minerals and rock from the surface. Again, miners remove soil and take minerals and rock from the surface. Placer mining: ships use a scoop. Ships use a scoop to take materials from the bottom from the bottom of lakes or oceans. Of lakes or oceans. Again, ships use a scoop to take materials from the bottom of lakes or oceans. Undersea mining. Miners use a scoop. Miners use a scoop on the bottom of the ocean. On the bottom of the ocean. Miners use a scoop on the bottom of the